Hi guys, welcome back to another video. This is our second video in the polynomial series, and I'm just going to be going over the remainder theorem, what it is, how it works, and how you can apply it to questions, and also just use it to double check answers to make sure that you got the questions right after you finish doing them. So the remainder theorem just states that if p of x is divided by x minus a, the remainder is p of a. Alright, so how do we put this in a practical sense? Well, let's zoom in a little bit here actually. So let's say our p of x is x cubed minus 4x squared minus 7x plus 10. And we're dividing it by x minus 2, for example. We take this a here, so our 2, and we put it into this x spot. Alright, so we're grabbing it, putting it in there, p of 2 equals, and then you just replace all the x's in here with that same 2. So 2 cubed minus 4 2 squared minus 7 times 2 plus 10 equals 8 minus 16 minus 14 plus 10 equals negative 12. So we know if we divide this term up here, p of x, by this term down here, x minus 2, we will have a remainder of 12. Now why is, negative 12, sorry. So why is this useful? Well, this is actually useful for, like I said earlier, double checking answers, and it's also useful for finding factors of large polynomials, because quadratics are easy enough to factorize, but if you're trying to factorize a bigger number, it can get a lot more tedious. So essentially what we're doing is guessing and checking, but we're narrowing it down a lot more to try to speed up the process. So we'll use the same p of x. P of x equals x cubed minus 4x squared minus 7x plus 10. But what we're actually looking at is this constant term. So we are trying to sub in numbers that can multiply to make that constant term, and we know there's going to be 3 different constants that multiply to make it. So let's just think factors of 10. Let's try out 5. So we're dividing p of x divided by x minus 5, because it's x minus a. So we're plugging in that 5 over there. P of 5 equals, and then we just sub it in just like we did before, minus 4 times 5 squared minus 7 times 5 plus 10 equals 125 minus 25 times 4, 100, minus 7 times 5, 35, plus 10 equals 125 minus 35 plus 10 equals 0. So since this has a remainder of 0, that means that this x minus 5 here is a factor of p of x. And now we would use something like long division or synthetic division, which I will teach in later videos, to break down the polynomial further and get it to its lowest common factors, or just factorize it as far as possible, I should say. So that's the practical use for it. Another method is, if we come over here, if we're working with, I'll just use a simple example, p of x equals x squared minus x minus 6. Let's say we're really rushing in a test, we're getting through this as fast as possible, we just go, it's x minus 6, x plus 1, because those are 2 factors of negative 6. And we just left it at that. we went through and then we realized, oh, we've got plenty of time left, we've looked at the clock wrong or whatever, and you have time at the end, you come through and you double check. A really simple way of double checking this is just subbing in our a's. So -6 here, if we sub it in, p of 6, because it's x minus a, remember, a lot of people get confused on that point. You're essentially just picking the opposite number to whatever you think it should be. If you think it should be -6, it should probably be 6. So p of 6 equals 6 squared minus 6 minus 6 equals 36 minus 12 equals 24. So this doesn't equal 0. So immediately that lets us know we put the wrong answer here, and we should look back at it. Use our quadratic factorization methods, which we've been over before, and look at it and go, okay, what multiplies to make -6? -6 and 1 is one thing, but it can also be 2 and -3. So we try that. X plus 2, x minus 3. And we can try sub that in here. P of 3, for example, equals 3 squared minus 3 minus 6 equals 9 minus 3 minus 6. 9 minus 9 equals 0. And there we go. So we immediately know that that is a factor. And just for safe precautions, so we really need this mark. Let's just double check the other one as well. Since this is plus 2, this can be broken down into x minus -2, and our a is our -2 over here. Sorry for that notification. And so this becomes p of -2 equals -2 squared minus -2 minus 6 equals 4 plus 2 minus 6 equals 6 minus 6 equals 0. So we know both of these are factors, and we've now double checked our answers. We can say with certainty we're correct and save a couple of marks on an assessment. So those are two main uses of the remainder theorem. You can also get it as an individual question on its own, so it's good to know anyways, but really simple to remember, and the practical applications are incredibly useful. So this is one of the key things with polynomials. That's why I've made it video 2 instead of way later on, because when it's fresh on the topic, you tend to remember it a lot more, and you use it when you break down the larger polynomials, as I mentioned. So yeah, that's just about it. Thanks for watching, and see you in the next one.